All I'm offering is the truth, nothing more.
The screen in your pocket is a miracle. It contains the world, but that miracle is a lie. Strip away the glass, the battery, the electricity, what remains? The pure logic that powers everything. This foundation, the entire structure of digital thought, was forged in an analog past, drafted without a single machine, proven only by human genius. The code was finished before the computer was even started. The story of modern computing, or what we now call code, doesn't begin with microchips or machine. It begins with something far more powerful, pure human imagination. Today we're going to trace this remarkable journey. We'll travel from ancient mathematical puzzles to groundbreaking mechanical inventions and finally to the sophisticated programming languages that shapes everything around us. It's a path filled with curiosity, creativity, and centuries of brilliant thinking. By understanding this history, we begin to appreciate the depth of intelligence and innovation that built the digital world we rely on every single day. It reminds us that technology isn't just made of code, it's made of human ambition. Now, let's look at how coding first began. The story begins in the 9th century with the mathematical foundation of coding. The very word algorithm, which we use today to describe a clear step by step method for solving a problem, comes from the name of the Persian mathematician Al Khwarizmi. His work introduced systematic and logical problem solving methods that allowed complex calculation to be broken down into simple, repeatable steps. These ideas form the intellectual backbone of programming, meaning that every modern programming language still relies on the principle he established more than 1,000 years ago. In many ways, modern code is built directly on his mathematical framework. Moving forward to the 1800s, we see these abstract ideas take physical form through mechanical instructions. The Jacquard became the first machine in history to follow a programmable sequence of commands. It used punch card to control viewing patterns, where holes represented an on instruction, and then the absence of holes represented an off instruction. This created an early form of binary logic. Although simple, this innovation proved a powerful concept. Machine could be programmed to follow precise instructions long before electricity or computer existed. Shortly after, the idea of programming was expanded even further by Ada Lovelace, often recognized as the world's first programmer. While working on Charles Babbage's analytical engine, she wrote what is considered the first computer algorithm. More importantly, Lovelace understood that machines could do far more than just perform calculation. She realized that they could follow long chains of instruction to carry out general tasks. Her vision went beyond the technology of her time and accurately predicted the future of computing nearly a century before it became a reality. Finally, in the 1930s, the theoretical blueprint for modern computing was established by Alan Turing. He introduced the concept of the Turing machine, an imaginary device capable of performing any calculation provided it was given the correct set of instructions. This idea became the mathematical foundation of all digital computers. Turing's work proved that even the most complex problems could be solved by breaking them down into precise, logical steps, exactly the principle that modern coding follows today. As electronic computers finally become a reality, the ideas behind coding were no longer just theoretical, they were put into practice. However, early programming was far from user-friendly. Programmers worked directly with machine code, long sequences of binary digits made up of ones and zeros. These instructions were easy for machine to understand, but extremely difficult for human to read, write, and debug. Programming at this stage required deep technical knowledge and absolute precision. To solve this problem, assembly language was developed. Instead of memorizing endless binary sequences, programmers could now use short symbolic commands such as add, load, or jump. These words were still closely tied to the hardware, but they represented a major breakthrough. For the first time, programming became more readable and manageable for humans, marking the first step toward modern software development. In the 1950s, programming took another major leap forward with the introduction of a high-level language such as Fortran and COBOL. These languages were designed to resemble human language and, importantly, to work across different computer systems. Programmers no longer needed to write their code for every machine. High-level languages introduce essential concepts that are still used today, including variables for storing data and loops for repeating actions automatically. This shift allowed programmers to focus less on how the machine worked internally and more on solving real world problems efficiently. The impact of this evolution is clearly visible in the modern world. Today's high level languages such as Python, JavaScript, and C++ are incredibly powerful and flexible. They form the invisible infrastructure behind everyday life. Code runs global financial markets, powers navigation system, manages healthcare records, control transportation network, and build every application on your smartphone. In just a few decades, programming have evolved from controlling simple machine to managing entire system and industries that society depends on. Perhaps the most remarkable aspect of coding evolution is its collaborative nature. Millions of programmers around the world now work together on massive open source projects like on GitHub. They share code, improve one another's ideas, and collectively build technology that anyone can use. This global cooperation accelerates innovation and ensures that digital world continues to grow, adapt, and improve and at an extraordinary rate. We have now followed the extraordinary journey of code, how it began as pure mathematical logic in the hands of Al-Khwarizmi, how it took physical forms in mechanical inventions like the Jacquard loom, and how pioneers like Ada Lovelace and Alan Turing shaped its rules and possibilities long before digital computers existed. Today, those early ideas have grown into the powerful, high-level programming languages that drive our digital age. Everything from artificial intelligence to global communication rests on the foundations laid by these early thinkers. The story of code is more than just the story of technology. It is the story of centuries of human imagination, experimentation, and problem solving, slowly building the complex digital world we rely on every day. And the next time you open an app, send a message, or browse a web page, you're touching the end result of that long history. So remember that behind every click, every search, every device and system in your life, there stands a chain of brilliant minds stretching back 1,000 years, people who dared to imagine how ideas could become instructions and how instruction could shape the future. That's all from me. Thank you.